Hi guys, today we'll be finishing lesson 12, starting at the third student task statement called Up and Down with the Picards. Question 1. Challenger Deep is the deepest known point in the ocean at 35,814 feet below sea level. In 1960, Jacques Piccard and Don Walsh rolled down in the Trusette and became the first people to visit the Challenger Deep. Part A. They said, if sea level is represented by 0 feet, explain how can you represent the depth of a submarine descending from sea level to the bottom of the Challenger Deep. Okay, so basically, I'm going to draw a number line, or a vertical number line, and I'm going to draw some water. So this is at sea level, and they're saying that at sea level, it's being represented at 0. At sea level is represented by 0. And it wants you to know, well, what would it be below sea level? What integers could we use to represent below sea level or to represent descending? And, of course, this would be negative numbers. We could use negative numbers. Our integers. Okay? Because it's below sea level. Positive numbers would indicate above sea level. All right. Now for part B, I'm going to write this down underneath here because I don't have that much space, but I'm pretty sure you guys will have space in your book. So feel free to use the space in your book, but let's jump to part 3. It says Trusette descent was a change in depth of -3 feet per second. We can use the relationship y equals -3x to model this, where y is the depth in feet and x is the time in seconds. Using this model, how much time would the Trusette take to reach the bottom? Okay, so I'm going to write down, or let's highlight some things that's important for us to remember. Y is representing the depth, x is representing the time, and they want us to use the model, and the model is y equals 3x, to find out how much time, I'll circle the question, how much time would it take the Trusette to reach the bottom? Okay, so I'm going to set up my equation, because that's what they want us to use, -3x. So they did give us a depth, and that is 35,814 feet below sea level, which would be a -35,814 feet. So this is equal to y. That's what y equal to. So if I was to plug, and we don't know what x is. We don't know what x is, so that's a question mark, but we do know the rate, which is -3. So if I was to plug this into my equation, I would have -35,814 feet is equal to -3x. So this is now a one-step equation. Now you should have learned about one-step equations in sixth grade, but if you didn't, the key to solving equations is trying to isolate the variable to figure out what it is. Okay? Anytime you see a coefficient next to a variable is a symbol of multiplication. All right? So I want to isolate this variable. So since it's -3 times this number, is going to give me -35,814. So what I want to do is I want to use the multiplicative inverse to isolate that variable, or we could just divide by 3 on both sides. All right, that cancels out, and now x will be equal to -35,814 feet divided by -3. Okay, now once I divide that, I should get x is equal to a positive 11,938 seconds. Okay. So now, moving on to part C. It says it took the Trusette 3 hours to ascend back to sea level. This can be modeled by a different relationship, y equals kx. What is the value of k in this situation? All right, so we're still going to use the same model to find this answer. All right. However, in this case, the constant is missing. All right. So y equals kx. All right. So our y will still be 35,814 feet. Okay. Our constant is missing. X is 3 hours. Okay. Now, piggybacking back to the equation, I want to plug in what I have. So I have 35,814 feet. And then I have K is missing and the time is 3 hours. But before I plug that 3 in, they're using seconds for unit rate in this. And we want to keep it consistent. Let's continue to use seconds. All right. So what I want to do is I want to convert 3 hours into seconds. So I'm going to multiply 3 hours times 60. Then I'm going to multiply 3 hours times 60 again. The first 60 represents minutes. Why? Because there's 60 minutes in 1 hour. So I need to find out, well, how many minutes are in 3 hours? And then once I find out how many minutes are in 3 hours, well, there's 60 seconds in 1 minute. So I need to figure out how many seconds. So I multiply each one by 60, and I should get 10,800. All right. Now, true, even though the variable is standing in front, which it's usually not like that, but either or, multiplication is commutative, so it doesn't matter what order we put it in, but yeah, you traditionally see it like this. All right. So needless to say, I still want to do the same steps. I want to isolate that variable by dividing by the 10,800. Okay. When I do that, I should get a -3 and 3,200 feet per second. K is represented by the constant of proportionality, and the constant of proportionality and unit rate is the same thing. Okay. Now, technically, because I'm looking in the book, I'm comparing my answers. Technically, since they're going back up, okay, because I must have skipped a step. Since they're going back up, it will be a +3 and 3,200 feet per second because they're going back up, okay? If they were going down, because a -3 and 3,200 would mean they would be going back down, okay? So if you had any questions about question 1 in question 1 in the third student task statement, guys, please make sure you refer to your manager's Google Meet session, and I'll see you guys in question 2 of the third student task statement in the next video.